These are the examples for Algebra 1B, Credit 3, combined lesson 20.2 and 20.3. All right, so even though it's a combined lesson, it's actually a fairly quick lesson. Our first example is for problems 1 and 2. And we have the function f of x equals 7x times 8x minus 32. The directions are to find the zeros of each function using the zero product property. We'll explain what that is. And then graph those points only. That is, you are not required to graph the entire function, the entire parabola. All right, so how do we do that? How do we find our zeros? So our zeros are the values of x that make the function equal to 0. So what values of x would make this equal to, if we set this equal to 0? In fact, we can even write it like that. Let's go ahead and do that so we can do more than just visualize it. All right, so when we're multiplying and get 0 for an answer, the only way for that to happen is if one of the numbers or one of the terms that you're multiplying is 0. That's the only way to get 0 for an answer, is if at least one of the terms is 0. It's okay if both of them are 0, but at least one of them has to be 0. So we have, what we want to see here, even though we have 7 times x times 8x minus 32, we want you to see this as two separate factors, the 7x and then the 8x minus 32. So either one of these could be 0. Either the 7x could be 0, because if that's 0, 0 times whatever this is will be 0. Or the 8x minus 32 could be 0, because if that's 0, then 0 times whatever this is would be 0. And so what we're going to do is just solve each of those equations, and then we have our two answers. So here, x is being multiplied by 7. So the opposite of multiplying by 7 is dividing by 7. The 7's cancel, and 0 divided by 7, or 0 divided by anything, is 0. So interestingly enough, one of our zeros is the number 0. One of our values of x that makes the function equal to 0 is 0. Is that always true? Not necessarily, but in this case it is. In our second equation, we have two steps because we have to get rid of the minus 32, and then we have to get rid of the 8. The opposite of subtracting 32 is to add 32 to both sides. And of course, the whole reason of doing that is so these 32s would cancel out. We bring down the 8x, and then 0 plus 32 is 32. Our second and final step, x is being multiplied by 8, so we divide 8 to both sides. The 8's cancel, and we have x equals 32 divided by 8, which is 4. And so our other answer, our other zero, our other value of x that makes this function 0 is if x is 4. And the way it does that, 8 times 4 is 32. 32 minus 32 is 0. And then 0 times whatever this would be, doesn't matter because 0 times anything is 0. All right, so now they want us to graph just the points. So if you do not like graphing, this is probably about as easy as it gets for graphing. In fact, we only need to put some of the y-axis, whoops, I already have 0 there. I'm sorry, we only need to put some of the x-axis points here. So our solutions are x equals 0 and x equals 4. We only have to plot the points. This is x, so we're going to be on this x-axis here. So all we have to do is put a point at 0 and then a point at 4. And then that's it. We are not sketching in the parabola. We're just trying to emphasize that these solutions, the solutions here algebraically, the zeros, if you will, are the x-intercepts, are where the graph, whether it would open upward or downward, actually it's positive, it would open upward, but regardless, the points where the graph crosses the x-axis, those zeros, those x-intercepts are the solutions. And that's all you have to do there. That is it. All right, now for problems 3 and 4, we have a word problem. We'll read number 3. It says, James Rodriguez strikes a soccer ball during penalty kicks. The arc of the ball can be mapped by the function. In our example, we're going to use f of t equals negative 5t times t minus 7 times t plus 9. How long does the ball spend in the air? Now, number 4, it's about a football, similar situation. Oh, one other point. Before I leave numbers 1 and 2, I want to point out, because on number 2, you're actually going to have a plus here. So Notice what was minus, so we added, but if it's addition, then you would subtract. You do the opposite. Just want to point that out. Anyways, over to our example for 3 and 4. What we want you to view this as here, once again, we're trying to find the zeros, because the question is how long does the ball stay in the air? How long until that ball hits the ground? So we have 3 factors here, the negative 5t, the t minus 7, and then the t plus 9. And if any one of those factors is 0, then the whole thing is 0. So we want to find out what value of t makes negative 5t 0. Let's go ahead and draw a line here. Or what value of t makes t minus 7 0. Or what value of t makes t plus 9 0. In other words, we're going to set each of these 3 factors equal to 0 and then solve. Our first equation, t is being multiplied by negative 5. So we divide by negative 5, and we get 0 divided by anything is 0, so t equals 0. Our second equation here, we have a minus 7, so we have to add 7 to both sides. The 7's cancel, and 0 plus 7 is 7. Finally, our last equation, we have a positive 9. The opposite of adding 9 is to subtract 9 to both sides. The 9's cancel, and then 0 minus 9 is negative 9. So now remember, the question is how long does the ball stay in the air? Well, you say, well, what do we do? We got 3 answers here. But whenever it's a word problem, we want to examine our answers closely because what we sometimes have extraneous answers. These are answers that are valid solutions. These are all correct solutions to each of our equations. But to answer our question about how long the ball stays in the air, it turns out only one of them is going to make sense. So let's remember now the time is in seconds. So this is 0 seconds, this is 7 seconds, this is negative 9 seconds. So at 0 seconds, yes, the ball is on the ground, but that's not when the ball returns to the ground. That's when we initially kick the ball. So that doesn't answer the question how long the ball stays in the air. So while it's true, a true statement that the ball is on the ground at time equals 0, right as we kick it, that doesn't answer the question. Now let's look at negative 9 over here. Negative 9, now again, this parabola does not know that it's part of a word, or this equation does not know it's part of a word problem. So it generates a negative answer. So there is a point, if the parabola, and if we have a negative here, so it would be a downward facing parabola, there is a point over here on the negative x-axis, specifically at negative 9, where it does intersect the x-axis. However, to say that the ball is in the air for negative 9 seconds is, well, for lack of a better way of saying it, nonsense. And so we would eliminate that answer as not answering our question either. So the only answer that makes sense is that the ball is in the air for 7 seconds. So our answer would be 7 seconds because it's the only positive answer that we have there. So if we were to graph this, we would see that the parabola, let's move this over just a little bit, intercepts, remember the x-axis represents the ground at negative 9, but we already said that's not a legitimate answer. And then also over here at 1, 2, 3, 4, 5, 6, 7. And that would be our answer, 7 seconds until that ball hits the ground. All right, so that is it for the examples for our combined lesson of 20.2 and 20.3. As always, pause and rewind the videos. We'll move out of the way with everything on the screen there, so you can, if you want to pause and study that, you can. So pause, rewind, and good luck with the work. And then until the next video, excuse me, take care and God bless. All right, bye-bye for now.